Hello everyone and welcome back. My name is Mr. Koval, and in this video I'm going to be going over physical versus chemical properties. As you recall, in my last video I went over physical versus chemical changes. And so to recap that, remember that a physical change is a change where there is no change in the composition of the substance. It's just a change or alteration in the appearance or phase that the substance is in, like gas to liquid, liquid to gas, that sort of change. A chemical change is a change where the substance actually changes into a different substance. So take the burning of a piece of wood as an example. So if the wood burns, as the wood becomes something different from what it was before. It becomes ash, smoke, carbon dioxide, things like that. So that is a recap of physical versus chemical changes. Well, what about physical chemical properties? Well, they're very similar to changes, but slightly different. So the thing you want to remember is that when we are talking about changes, we're talking about an activity, something that is happening in the moment, right? So burning wood, wood is burning, right? The rusting iron, iron is rusting, it's undergoing a process, it's undergoing an activity. So that's a change. When we're talking about properties, we're talking about the way something is, the characteristics of that thing, what it can undergo, what can happen with that substance under certain conditions. Not that it's undergoing any change or nothing, not that anything's happening to the substance at the moment, um, but that something could happen, right? That's one way to kind of understand what we mean by property versus change. So, what about physical properties? Let's begin with that. Well, a physical property is a property that a substance displays without changing its composition, i.e., undergoing a chemical change, right? So, without undergoing a chemical change, I can view that the tabletop is black, right? I just look at it. I'm using my senses to observe the world around me. So I see the tabletop and I see, okay, it's black. Now, did the tabletop have to change into something else in order for me to see the blackness of the table or for it to display that characteristic, that property? Well, no, because I can see it without it undergoing some sort of chemical change, without it going into something else or converting into something else, right? So examples obviously would be odor, like I can smell the odor, right? I can taste, right? That would be something that I could do without changing the substance. Smell and odor is kind of the same thing. Density, right? I can measure the density of the substance and it will still be the same substance, right? What is density, right? Density is mass in volume, mass per volume, right? So if I can measure the mass of something and measure the volume of something, then I can find the density. Well, measuring mass and volume isn't going to change the substance. It's going to stay the same, right? If I have a if I have an iron nail, for example, I can get the mass of the nail and I can get the volume of the nail by displacement, right? And so I can get those, and it'll still be a nail. It'll still be iron, right? Melting points, right? Melting point and boiling point. I can find those without changing the substance. So, for example, right, I can take an ice cube, right, solid water. I can find the melting point by raising the temperature of the ice until it starts to melt. The point at which it starts to melt is the melting point, the temperature at which it will melt. But undergoing that process, during that process, I'm not changing what the substance is, right? It's still water as it's melting, right? So I can find the melting point and the boiling point of substances without changing what it is. So those would be physical properties. What about chemical properties? Chemical properties are properties that a substance will only display by changing its composition. So usually through a chemical reaction. So in this case, I cannot observe with my five senses what that this property is in this substance. I shouldn't say in, I guess, but that this substance has this property without changing the substance, without causing a chemical reaction to occur in order to bring out and display that property. So, for example, flammability, right? I can show you, or I can cause a piece of paper to display or show the property of being flammable only by burning the piece of paper. I have to light it on fire, and then once it's lit on fire, it is now displaying the property of flammability. But if I don't light it on fire, I can't observe that flammability. But by lighting it on fire, I'm causing the paper to undergo a chemical change. And so it's going from one substance to a completely different substance. So that's the only way I can observe or cause the paper to display that property. Same thing goes with toxicity, right? Is this substance toxic or not? I have to cause it to undergo a chemical change in order to see that. Acidity, same thing. All of these are kind of falling under this idea of reactivity. Is the substance reactive? Well, in order to display that property of reactivity, I have to get it to react. But in the process of undergoing a chemical reaction, it's going to change into something different, right? And undergoes a chemical change. And that, ladies and gentlemen, is the difference between physical property and chemical property. I hope you enjoyed this video. If you did, then please like the video, share the video, hit that like button over there. Make sure you subscribe to my channel. And when you do, make sure you hit that notification bell. And when you do hit that notification bell, make sure you hit all so you can be notified by all the videos I put out. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me and have a great day.